Very good morning to our lecturer, Dr. Kairu. Today we'll be presenting on the metal distribution. My name is Wu Xiangjun, and my partner is Alani Wahi. And I'll first give an introduction to this aluminium element. So, aluminium is actually rarely found in nature. It is instead found in most rocks, particularly igneous rocks as aluminium silicate minerals. You can find aluminium in mica or actually feldspar. So mica and feldspar, the main component of these two minerals is aluminosilicate. And aluminium has only one oxidation state, which is positive 3. It also occurs ubiquitously in the environment in the form of silicates, oxides, and hydroxides. It can also combine with other elements such as sodium or fluoride, and also it can form complexes with organic matter. So I'll be talking about the distribution of aluminium in the environment. So aluminium in the air, it actually leaches into the air naturally through the flux of dust from soil, because as we know, soil naturally has aluminium, and also through the weathering of rocks that contains aluminium. It can also be released into the air through the volcanic emissions, as these volcanic emissions have aluminium. But although it is mostly released to the air through natural sources, it can also be released through anthropogenic activity, such as the combustion of coals in energy-producing plants, or aluminium-producing facilities, and also other industrial activities such as smelting and motor vehicle emissions. So the transport of aluminium into the water, for example, bauxite processing. So just as I said just now, aluminium is rarely found in nature, but how we get our main source of aluminium is through bauxite. And the way to process this bauxite to extract out the aluminium is actually very complicated. And we have factories specifically just to extract the aluminium from bauxite. And although these factories are beneficial for us as they give us our source of aluminium, but they also release a lot of effluent that contains aluminium into the surrounding water sources. Aside from the aluminium manufacturing facilities and also bauxite processing factories, the use of alum as a coagulating agent, although it's beneficial, it's advantageous, and it treats our raw water system, but the finished water may contain residual aluminium, which may be harmful if it exceeds a certain standard permissible limit. Also, mining activities can release large quantities of sulfuric acid and also aluminium into the air. And when it's dispersed out into the air, the wet disposition will lead to acid rain, which will then contaminate the surrounding water sources. And in terms of soil, it is also found in soil complex with other anions, as aluminium is a positive 3, so it will react with anions with negatively charged ions, such as fluoride, sulfate, and also phosphate. Aluminium is also released to the soil as a major constituent of many mining waste, and also in the solid waste from energy-producing plants, as energy-producing plants combust. They use coal for combustion to produce energy, and the solid waste from these energy plants have a lot of aluminium. Biota can also absorb aluminium in the form of organometallic compounds, oxy-anions of aluminium, and dissolve organic and inorganic metal complexes. Because the uptake of root crops of plants for aluminium is of particular more significant than animals. So I'm going to be talking about the issues with aluminium. Just like I said just now, the absorption of aluminium of the plant roots is of particular importance, as it changes the morphology of the root system of plants. The decrease of the absorption of mineral substances and the inhibition of cell divisions and elongations will lead to disturbances of important processes that determine normal growth of the root system. So the normal growth of the root system is like what you can see on the image on the right. 10 days old wheat seedlings grown in soil selected for a range of extracted aluminium. On the left is the low aluminium, and on the right is the high aluminium concentration. And because of the high aluminium concentration, elongation of roots will be inhibited. Aluminium toxicity will also cause weakening of immunity from diseases and resistance to pests, resulting in premature physiological aging. So next, I'll be talking about aluminium influence on animals. Aluminium, how they affect fish is that high concentration in the surrounding water of the fish. Aluminium will accumulate in the gills of the fish and cause blockade of ion exchange and respiration. While in frogs, it will not affect the respiratory, but affect the reproductive system instead. But the most prominent effect of aluminium concentration, high aluminium concentration in animals, is actually in the birds because of the thinning of eggshells, as it will affect the efficacy of calcium absorption. And as for humans, aluminium is known to be aluminium 3+ ion is actually known to be a neurotoxin to human systems. And long-lasting uptakes of significant concentration of aluminium can lead to dementia, Alzheimer's disease, and also bone problems. Mining workers, also workers in factories, to be related with pulmonary fibrosis. So pulmonary fibrosis is it means where the lung tissues are actually scarred, respiratory problems or the whole respiratory systems, and oxygen cannot be fully diffused into these tissues. Inhale more finely divided aluminium and more aluminium oxide powder. And also, in occurrence in food, aluminium as a common element in the natural environment, it occurs in almost all food products as well. The main products that supplies aluminium to our human organisms are cereals, cheese, salt, herbs, spices, and tea. An additional source of aluminium is also aluminium salt products or to facilitate food processing. And aluminium cans, tubes, and foils are also used in the food industry for wrapping and also packaging, which will contribute to food pollution with aluminium. It may be an issue for people who have a chronic kidney disease, as people with chronic kidney disease, they cannot expel aluminium from their body that well. Yeah. So that's all for me. I'll move it to Alani's part.
Okay, so now I'm gonna talk about the recent speciation techniques in analyzing aluminium 3+ ions. So under acidic or alkaline conditions, in the presence of complexing ligands, the solubility of aluminium compounds is enhanced, making it more available for biogeochemical transformations, therefore forming Al3+ ions. So this ion is related closely to the toxicity level of aluminium presence in the matrices explained by XJ just now. So the toxicity means the chronic effect of Al compounds is often connected with mortality of some animals and Alzheimer or some other human neurodegenerative diseases. So to analyze this certain type of ion, several analytical techniques are used. So for example, atomic spectrometry principle involves electrothermal vaporization inductively coupled plasma optical emission spectrometer and optical emission spectrometer with lasers. Mass spectrometry principle, on the other hand, uses accelerator mass spectrometer, time of flight mass spectrometer, as well as laser microprobe mass spectrometer. Molecular spectrometry principle uses fluorimetry, infrared spectroscopy such as FTIR, and nuclear magnetic resonance. X-ray spectrometry principle includes X-ray fluorescence spectrometer and energy dispersive X-ray microanalysis. All right. Computer modeling such as GeoChem analyzes the complexes within organic ligands. Alchemy analyzes the speciation in acidic stream from spruce forest soil. Solmine Q88 analyzes the speciation in mine soil solution. Minical Plus analyzes speciation from terrestrial quartz soil, spring and surface waters. WHAM analyzes the complexes and speciation in soil samples. So these computer modelings are differentiated by the matrices that are being analyzed. Okay, so now we're going to talk about the case study that we chose. It is written by Faradiela Muhammad Kusina et al. And the title is Distribution of Heavy Metals and Metalloid in Surface Sediments of Heavily Mined Area for Bauxite Ore in Pengerang, Malaysia, and the associated risk assessment. So as XJ mentioned earlier, the source that we get, the aluminum source that we mostly get in the nature is by the process of getting bauxite. The sampling area is in Pengerang, Johor, and there are 7 sampling locations chosen. That includes nearby rivers area, mine tailings, and ex-mining ponds. And from each sampling stations, 0 to 20 centimeter deep salt sediments are being taken. So this sample are then preserved by placing it in Ziploc bags and then stored in ice box. This is by referencing to the EPA method 3050B. And then the sample is then prepared by air drying and homogenizing each samples from the locations. And the samples are sieved through 2 millimeters sieve. And then it is being acid digested. It is applied for the extraction of heavy metals using hydrochloric and nitric acids, 3:1 ratio. And then the suspension from the acid digestion process is filtered through 0.45 micrometer membrane filter. Okay, next slide. Okay, and then these samples will be analyzed using ICP-MS. So it uses the mass spectrometry analysis. The suspension is placed in centrifuge tubes, and then the heavy metals are analyzed. For QA and QC procedure, the analytical instrument was checked with standard reference material. And then the percentage of recoveries for the metal study ranged between 82 to 117%. It is considered as eligible. Okay, next. This is the mean concentration from the analysis done before, and in the red box is shown for the aluminum concentration found in each of the sampling stations. And as you can see, the concentration is quite large compared to the other heavy metals, and the reading is quite similar to the iron concentration found. Next slide. Okay, the high aluminum concentration found can be explained by the weathering and intense leaching of geological components, such as silicon. So the formation of aluminum hydroxide means higher aluminum 3+ ion concentration in soil. Therefore, the concentration ranking can be seen as shown. So ferrum and aluminum are considered as the top tier in the concentration ranking. Okay, next slide. As I mentioned before, the reading of the concentration reading of ferrum and aluminum are quite similar, as you can see from the graph. And this is because Fe and ferrum and aluminum are important in the stabilization and formation of most soil aggregates. So that's why it can be found majorly in the reading. So to the last slide, the risk characterization. From the reading of concentration of aluminum found, it has an index have been calculated to be lesser than 1. Therefore, it possesses non-carcinogenic effects. And therefore, the toxicity is still considered low despite the high concentration reading. However, children are the most susceptible um, to high aluminum concentration, and the pathway of aluminum reaching to humans are ingestion, dermal, and inhalation. So ingestion causes more intake compared to dermal and inhalation. And as XJ has presented before, aluminum can be found in food samples. So yeah, I think that's all from us. Thank you.